This is my third time recording this video. How appropriate, since there are just 3 more theorems. The first theorem is called the congruent complements theorem. This is very similar to the congruent supplements theorem, so it should sound familiar. If 2 angles are complements to the same angle, or congruent angles, then the 2 angles are congruent. So let's look at it as figures. You will notice angles 1, 2, and 3 here. So if angle 1 and angle 2 are complements, and angle 1 and 3 are also complements, then angle 2 and angle 3 must be congruent. You'll prove this pretty much the same way you did the congruent supplements theorem, but instead of the sums of the angle measures being 180, they will be 90, and instead of the definition of supplementary, you'll use the definition of complementary. Our next angle is the right angle congruency theorem. It merely states that all right angles are congruent. So looking at our figure here, you will notice that both angle 1 and angle 2 have the right angle symbol in them, which tells us that angle 1 and angle 2 are right angles. And since they are right angles, then they must be congruent. This one is really easy to prove. Use the definition of right angles to indicate what their measures are, then use the definition of congruent angles and those measures to finish your proof. And finally, we have the congruent and supplementary angles theorem. This says that if 2 angles are congruent and supplementary, then the 2 angles are right angles. So here we have a figure with angles 1 and angle 2. And you will notice that they are marked as being congruent. So we know that they are congruent, and we're also told that they are supplementary. So angles 1 and 2 are congruent, and they are supplementary. Therefore, they must be right angles. Let's go ahead and prove this one. You will notice that we've started off with the theorem itself written down here. Our hypothesis is that 2 angles are congruent and supplementary. So that is what is given. We have 2 angles that are congruent and supplementary, and then we are also told that those 2 angles are right angles. So that is what we are going to try and prove, that the 2 angles are right angles. But instead of using general words, let's use a figure. So here we have a figure, and we are given that angle 1 is congruent to angle 2. Notice the congruent marks down here. We are also told that angle 1 and angle 2 are supplementary. This is part of our hypothesis, so therefore it's part of our given. And we need to prove that angle 1 and angle 2 are right angles. So let's just jump right in and do this. A good place to start is with something that's given. So let's start with the fact that angle 1 is congruent to angle 2. But something that's probably going to be more helpful to us is the answer to this question. What does it mean for angles to be congruent? We can look up the definition of congruent angles and discover that that means that their measures are equal. So the measure of angle 1 equals the measure of angle 2. I think that's about as far as we can go with that particular piece of given information. So now let's go to the next piece. Angle 1 and angle 2 are supplementary angles. I'm going to do the same thing that I did with the last one and ask the question, what does it mean to be supplementary angles? So if I look up the definition of supplementary angles, I find out that that means that the measures of the 2 angles added together are going to equal 180 degrees. This came up in the congruent supplements theorem. Please notice that there are patterns that begin to develop with these proofs. So the more proofs you do, the more patterns you see, the easier they become. All right. Where are we at here? I have an equation sitting here that says that 2 angles added together equal 180 degrees. And I also have a statement up here in 2 that says one angle measure is equal to the other. Why don't we use the substitution property of equality and move angle 2 from step 2 into the equation for step 4. That will give us that the measure of angle 2 plus the measure of angle 2 is equal to 180 degrees. Notice I just replaced the measure of angle 1 with the measure of angle 2. That gives us a set of like terms here. And what allows us to add these like terms together? That would be the distributive property of multiplication over addition. So if we add those together, we have 2 times the measure of angle 2, and that still equals 180 degrees. But now let's get rid of this 2 right here. How do we undo multiplication? Using the division property of equality. So if I divide both sides of the equation by 2, I find out that the measure of angle 2 is equal to 90 degrees. Oh, now wait a minute. Earlier we said that the measure of angle 1 is equal to measure of angle 2. Now we're saying that the measure of angle 2 is 90 degrees. That allows us to say that the measure of angle 1 is also equal to 90 degrees. To use the transitive property of equality, and it looks like I jumped the gun. There's actually 9 steps here. Notice what we have here in steps 7 and 8. What kind of angles have measures of 90 degrees? You guessed it, right angles. So therefore, angles 1 and 2 are right angles. And what told us that? That's the definition of right angles. Yes, this proof had quite a few steps to it, but none of the steps were extremely difficult if you know your properties and your definitions.